Okay, so we've just observed that functions are objects and two names can point to the same function object. We have also seen that a function can accept another function as an argument. We are now going to learn about closures, which will help us when learning about decorators. But before getting into what a closure is, we have to first recap what a nested function and a non-local variable is. I'm confident you will know what these are already based on learnings earlier in the course, but let's recap for good measure. Now, a function defined inside of another function is called a nested function, which we saw in the prior video. Now, when it comes to nested functions, they can access variables of what is known as the enclosing scope, and we've also touched upon scope in an earlier video. Let's see an example of a nested function accessing a non-local variable. So if we create a function called greeting, and inside of parentheses pass in a parameter called message, and then put a colon, the body of the function that we define with one indentation would be what is known as the outer enclosing function. Now, if I was to now define another function, so let's put def welcome with a set of parentheses and a colon, this is then what is regarded as the nested function, i.e. we have a function nested inside of another function. So let's have it so that the welcome function simply prints out what is passed in as message. Now notice here that message is passed in to the outer enclosing function, and we're looking to access this in the welcome function without passing it in as a parameter. What we can then do is have the greeting function call upon the welcome function. If we now execute the greeting function and pass in the argument hello into the message parameter, you can see that we print to the screen hello. So this example clearly demonstrates that the nested function is able to access the non-local variable, in this case message because it's defined above, of the enclosing function. We haven't had to stipulate message in the welcome function, we've stipulated it in the outer enclosing function. Okay, so that's the first thing to note. Now what would happen if the last line of the greeting function where we've called upon welcome returned the welcome function instead of calling it? So let's copy and paste this code cell, and where we've called welcome, let's simply return the name welcome, which we know is bound to a function object. In other words, we don't need to put parentheses when we return this function. If I now create a new variable called new_name and set this equal to a call on the greeting function in which we pass in the string hello, because we are now returning the welcome function when the greeting function is called, we know new_name will be an object of the type function. And just to prove this, if we pass new_name into the built-in type function, we do indeed get function returned. So if I now call new_name with a set of parentheses, because we can call functions, we get hello printed to the screen. Now does that seem strange to you? What's happening here is we're calling the greeting function and passing in a parameter. Now the greeting function actually returns a different function called welcome, which doesn't take in any parameter, and the new_name variable now has the welcome function bound to it. But when we then call new_name, the input of hello that we passed into the greeting function was remembered based on what we'd put in previously. Now this technique by which some data, and in this case it's the string hello that we've passed into the greeting function, the technique by which this gets attached to the code is called closure in Python. In other words, the value in the enclosing scope, so the hello string that we pass into the greeting function, is remembered even when the variable itself goes out of scope or the function itself is removed from the current namespace. And to show you what I mean in another example, let's now delete the greeting function. So if I put del greeting and then try to call upon the greeting function and pass in hello, we run into a name error telling us that the name greeting is not defined. But what if I tried to execute new underscore name, which was previously bound to a call on the greeting function, which we know returned the welcome function? Well, when I do this, we still print out the word hello. So the return function still works even when the original function, in this case greeting, is deleted. So this is something else to keep in mind, as it's useful when covering the concept of decorators. Okay, so just to recap, we have a closure in Python when a nested function, in this example the welcome function, references a value in its enclosing scope, with this example's value being the message variable. To create a closure in Python, we must have a nested function, in this example tick, welcome is nested. The nested function must refer to a value defined in the enclosing function, tick. We can see here we're printing message, which is defined in the greeting function. And finally, the enclosing function must return the nested function, which it is doing in this example. It's returning welcome. In the next video, we'll continue our discussion on closures and observe when closures are good to use. So I'll see you in the next video. Okay, so in the last video, we created a closure. So let's recap. We had a nested function inside of another function. So in this example, we had the welcome function defined inside of the greeting function. We had the welcome function inside its code body referencing a value that was defined in the enclosing function. In this example, it was the variable message. And finally, the enclosing function returned the nested function. In other words, the greeting function returned the nested function called welcome. We then created a new variable called new underscore name and set this equal to a call on the greeting function. Now, what does this piece of syntax here remind you of? Well, when we create classes, we create an instance of that class by writing very similar syntax. So closures can also be seen to provide an object-oriented solution to a problem that you may face. Now, you may be thinking, well, when do I use classes and then when should I use closures? Now, when you have a method or a couple of methods to be implemented in a class, closures can provide an alternative solution and a more elegant solution to the problem you may face. But when the number of attributes and methods that you want defined get larger and larger, it's better to store this in a class. So let me show you a simple example where a closure might be more preferable than defining a class and then creating instances of that class separately. Now, obviously, when it comes to development, you are the developer, you get the choice at the end of the day, but hopefully this gives you an idea as to when closures may be preferred over creating a class. So for this example, I'm going to create a function that enables easy multiplication of two numbers. So to do this, I'm first of all going to define an outer enclosing function which we're going to call base underscore multiple. We're then going to pass in one parameter name labelled base. I'm then going to put a colon. The second thing we need to do is create a nested function, so I'm going to put def, and the nested function will be called multiply underscore by. I will then pass in one parameter name which we'll label as x. I then want the function to perform the calculation, so I'm going to return base multiplied by x, and then I'm simply going to return the nested function's name, so I'm going to return multiply underscore by. Great, so we've now created our closure. We can now create a new object name, and let's suppose that we want a function that deals with multiples of 8. So to do this, I can create a new name called multiply underscore by underscore 8, and I can set this equal to a call on the function base underscore multiple, and inside parentheses here, I can pass in that base number 8. Now, because the multiply underscore by underscore 8 name is bound to what is returned, which in this case is the return on the multiply underscore by function, I'm now able to call upon the multiply underscore by underscore 8 name that will then perform the calculation accordingly. So if I now print to the screen multiply by 8 and then in brackets pass in 10, you can see that I get 80 returned to the screen. If I call this name again, but this time pass in 12, you can see we get 96 returned. So we've now essentially created ourselves an object that we can use that will always handle multiplications by 8. Using the same closure, let's create another instance which deals with multiplications by 15. So multiply underscore by underscore 15 can be the name. We can set this equal to base underscore multiple and then pass in the number 15. I can now call upon my new name, so multiply underscore by underscore 15, and in brackets I can pass in 2. When I run this code cell, we print 30 to the screen. And let's say we were interested in what 15 times 15 was. If I call upon multiply by 15 and pass in 15 to the parentheses, you can see we return 225. So we've been able to create a closure which returns that multiply underscore by function, and I can then create a new name which is a call on the outer function which returns the nested function, and then I can use this name whenever I want to in my code. Now why am I showing you all of this? Well, Python decorators make extensive use of closures. And you're going to see a lot of familiar syntax that I've just shown you when we discuss decorators. So hopefully you've managed to follow along with some of these concepts, as they will certainly help in subsequent tutorials. In the next video, let's get back into decorators.